In question 7b, once again, we are graphing a transformation of our parent function. So once again, we know that y is the square root of x is our parent function, and if that's the case, then we have ordered pairs. If we take the square root of 0, it's 0, the square root of 1 is 1, the square root of 4 is 2, and we're going to change those ordered pairs into the new transform data by all the alterations made to our parent function. So once again, things that we know about this is we know that anything inside is an x, anything on the outside impacts the y's or the verticals. So we have two vertical changes and only one horizontal. So I'm going to take care of the horizontal transformation first. The first thing I'm going to do is make sure that I add 1 to all of these x values. Remember, it's counterintuitive. It says subtract when you add 1. So 0 plus 1 is 1, 1 plus 1 is 2, and 4 plus 1 is 5. And on the y's, just as I explained in the other video, wasn't sure if you saw it, so make sure that you apply your GEMDOS and think about what would I evaluate first. When I evaluate this, if I multiply by 3, would I add 2 first? And this is going to be first because multiplication division comes first when you evaluate. Just subtraction comes second. So same thing I said in the other video. I don't know if you saw it, so I thought I'd plug that in there. So what we're going to do is the first thing we're going to do is we're going to take all of these x or y values and we're going to change them by multiplying them by 3. So 0 times 3 is 0, 1 times 3 is 3, and 2 times 3 is 6. And then we're going to come back, we're going to change all of those values by adding 2 to them. So now we're going to add 2 to each of these. So 2, 5, and 8. And we're going to graph the ordered pairs 1, 2, 2, 5, and 5, 8. So I'm going to go to my coordinate plane, graph the ordered pair 1, 2, then the ordered pair 2, 5, and then the ordered pair 5, 8. And draw my graph to those points as best as I can. And I want to locate this point down here because it really helps you with determining the domain and range. So at that bottom point where our graph begins is at 1, 2. Now we can describe the domain and the range fairly easily. The domain will be when x's, all the x's have to be greater than or equal to 1, because we can see all the x values go to the right. And the second part of it, where your y's determine what are your outputs. Your y's are always greater than or equal to 2 because they are always bigger than 2. So greater than or equal to 2 is your domain and range.